LLMs are very good at generating the next word, regardless of what you think you meant when you prompt them. For example, I told you to stop doing that. You've probably said this before and you've heard, okay, I'll stop. And then you say, no, you did it again. Promise me you'll never do that again. Absolutely, it's my fault. My bad. I promise I'll stop right now. These are just words. It doesn't know what it's saying. It has no facts and it doesn't reason. It can only do one thing: generate the next most likely word in response to your prompt. If you tell it to never do that again, it will look into its memory of millions of sentences where someone asks someone else to never do something again and give you the most likely answer, the most popular answer in all its training data, which is, I'm sorry, you're absolutely right. That's on me. I'll never do that again. And then it will happily make the same mistake the next time. If you yell at it and get upset, say, call it names or say, we're breaking up, it will just answer based on all the responses to all the upset questions and say, I'm very sorry. It's my fault. It won't happen again, I assure you. Let's try again. This will continue until it finally gives up, which usually takes a while, but it happens to me all the time because I'm always trying to push the limits to see what it can do and how confident or overconfident it is. LLMs process information in ways that produce behavior indistinguishable from understanding, but they don't actually know anything. What we can say is that they are very good at saying what an expert would say because they've trained on tons of expert material. But if the experts are wrong, the LLMs are wrong. When you see an LLM do math, it often looks very convincing. I asked GPT-5 to give me the pricing from its own API page, and it got the figures wrong. It can't make sense of these numbers. It can't say they seem high. I'd better double check. You have to either tell it to double check, or as I do say, ask it, does this make sense to you? And the answer is, oh, sorry, no, I blew it. Here, let me try again. My bad. And its math ability will get better and better until it makes the next mistake. But at the moment, it can easily translate a 1 into a 2 or a 5 or a 1 into a 27. Watch for numerical hallucinations. We're seeing a lot of use of video today to make ads, shorts, and all kinds of attention-getting eye candy. 80% of internet traffic is video. Like LLMs, video foundation models also train on millions of hours of video footage. You may remember early experiments where gymnasts had too many legs and actors had too many fingers, but most of that's gone now, or at least it's more subtle. The basis of these models are the diffusion models for creating images, but it didn't make sense to use a pixel or frame-by-frame diffusion model for video because it would have been far too expensive. Instead, video diffusion models get their understanding of physics, humans, animals, objects, lighting, continuity, characters, voices, and more simply by training on millions of video examples. No video experts needed. They use keyframes to anchor the story and interpolate between those keyframes one at a time. And this led to the breakthrough in text-to-video we have today. Sora 2 and Veo 3 can generate very realistic-looking images. The one thing they can't do is build a 3D model. Instead, it's all about keyframes and the next most likely frame in the sequence. It goes from one image to the next simply by imagining what the pixels for that next image are most likely to be, where the ball will be, where the feet will be, where the sun will be, and so forth. As the camera moves or the actors move, the AI simply predicts the next unseen pixels and how they probably look. There's no framework underneath. There's no model describing the unseen side. It has to guess. To make the frames look real, it has trained on millions and millions of videos. These generators get their knowledge of physics, lighting, and consistency from watching videos, not from getting instructions from experts. In fact, the process is very similar to how LLMs work. LLMs use attention layers to set the weights for relationships between words in thousands of dimensions. And this is called temporal spatial attention. Instead of words, the tokens are parts of images like faces, figures, foreground, background, dust, light, etc. This breakthrough has led to remarkably similar realism in film as we have in language. This 1-minute video interviewing people at a trade show was generated from a single prompt. LLMs and video diffusion models have seen millions of films and read millions of scripts. They will soon use keyframes to generate an entire film from a single prompt. I'll talk more about this in the impact video.